Sometimes the simplest things, like how fast you react, spark the biggest debates. We react all the time, instinctively. But back in the late 1800s, measuring that reaction time, well, that became a huge scientific battleground. Today, we're diving deep into that world, looking at early psychological chronometry measuring the mind's timing. Our guide is a key paper from 1895 by E.B. Titchener called Simple Reactions. And get this. The whole controversy kicked off because of a difference of just 1/10 of a second. So let's start there. What exactly is this simple reaction time they were measuring? And what was the big discovery that got everyone so worked up?
Right. So basically, simple reaction time is just that interval,
Okay.
from when you sense something, a light, a sound, to when you make a movement in response, the bare minimum time. The real breakthrough came from Ludwig Lange, working in Wilhelm Wundt's lab in Leipzig around 1886-87. He had something pretty crucial. Your reaction time actually changes depending on where you focus your attention.
Okay, attention. How so?
Well, Lange identified two main types. First, the sensorial reaction. That's where you focus all your attention on the stimulus itself, like really listening hard for that expected click.
Got it. Waiting for the signal. And the other type.
That was the muscular reaction. Here, your attention isn't so much on the incoming signal, but on the movement you're about to make. You're poised, ready to press that button, almost like a reflex.
Ah, okay. So one is about perceiving and the other is about acting. Makes sense. What difference did it make in timing?
A big one. Lange found the muscular reaction was consistently faster, like noticeably faster. We're talking about an average difference of around zero point 0.1 seconds or 100 milliseconds. Back then, they sometimes used sigma for milliseconds, so 100 sigma.
1/10 of a second. That doesn't sound like much today, maybe, but I guess back then.
Oh, it was huge. For sound, muscular could be like 125 milliseconds, but sensorial, more like 223. For light, maybe 172 versus 290 milliseconds. It was a really substantial measurable gap. Lange also stressed that, practice was really key to getting these pure forms, especially the sensorial one. It needed careful focus.
Okay, so Lange finds this clear difference based on intention. Seems solid. Why the big controversy then? What was the argument about?
Well, it sparked a major psychophysical debate. I mean, this was core to psychology, establishing itself as a science that could precisely measure mental events. And yeah, many researchers jumped in and confirmed Lange's findings. People like G. Martius, G. Walshavers,
Yeah.
they found the distinction held up. Titchener himself, in his own work, found similar differences, maybe 80 to 100 milliseconds.
So supporting evidence was there.
Definitely.
Yep.
But then you had prominent researchers pushing back. J. McKay Cattell was a big one. In his own 1895 paper, Cattell reported results from observers where there was basically no difference between the two types.
No difference at all.
None. And even more striking, in one case, the muscular reaction was actually slower than the sensorial one by about 80 milliseconds.
Whoa. Okay, that definitely throws a wrench in the works. How did Titchener, in his 1895 paper, deal with that kind of conflicting evidence?
Yeah, that's the core of his paper, really. Titchener carefully went through the counter-arguments. He argued that some studies just weren't controlled properly. Like, maybe the researchers didn't explicitly tell participants where to focus their attention on the stimulus or the movement. If you don't ask for those specific mental sets, you might not see the difference.
So, potentially flawed experiments.
That was part of his argument, yeah. For other conflicting results, like from Van Beervliet or Bliss, Titchener suggested maybe the participants just hadn't practiced the muscular reaction enough. It takes training to get that really quick, almost reflex-like response down.
Okay, practice makes perfect. But what about Cattell's result, where muscular was slower? That seems harder to explain away just by practice.
Right. For Cattell's findings, Titchener offered a couple of, more nuanced explanations. One idea was automatism. For someone very practiced, like Cattell himself, maybe the reaction became so automatic that the conscious focus differentiating the types just blurred. Or maybe if someone naturally leaned towards the sensorial type, forcing them to focus hard on the movement could actually inhibit it. Imagine tensing up so much trying to be fast that you actually slow down, like muscle cramping almost.
Interesting. So it's like overthinking it could slow you down.
Potentially, yes, especially without balanced practice in both types. So Titchener's conclusion wasn't that Lange was wrong, but that the distinction, while valid, might not show up in every single person without the right conditions. He used the term enlage, basically, a kind of natural disposition or aptitude. Some people might find it easier to adopt these distinct attentional sets than others. Lange himself and others like Wundt had kind of hinted at this too.
So the difference is real, but maybe not universal unless you have the knack or you practice a lot. Okay, I think I get the debate now. But why did it matter so much? A tenth of a second, specific attentional sets. Why was settling this crucial for early psychology? Why should we, listening now, care?
That's the million-dollar question, isn't it? It mattered because this wasn't just about reaction times, it was fundamental. First off, this simple reaction. They saw it as the most basic form of voluntary action. Studying it was like step one in understanding intentional behavior. And it was vital for training researchers. If you couldn't control your own attention well enough to produce these different reaction types, how could you be a reliable observer in more complex psychological experiments that relied on introspection?
Ah, so it was like a basic skill for doing psychology back then. Calibrating the instrument, which was the person.
Precisely. Yeah. But it went way beyond that. They used these reaction time methods to dissect more complex mental processes. They timed things like cognition, discrimination, making choices, associating ideas. For instance, finding that recognizing a whole word takes about as long as recognizing a single letter that tells you something deep about how we process language, right? In chunks, not letter by letter.
Yeah, that is revealing.
Or showing that distinguishing between qualities, like red versus green, is faster than distinguishing intensities, like bright red versus dim red. That helps shape theories about perception. And they proved that making a choice actually adds measurable time on top of just discriminating between stimuli. It quantified the cost of deciding.
So these simple timing differences open doors to understanding much bigger mental functions.
Absolutely. It even shed light on practice and fatigue. The muscular reaction tended to become automatic, almost a reflex, with practice. Less effortful. The sensorial one, less so. It stayed more consciously driven. This difference helped them think about different kinds of mental versus motor fatigue.
And did this have relevance outside the psychology lab?
Oh, definitely. Think astronomy, the personal equation.
Yeah.
Astronomers timing stars, crossing wires in telescopes, realized their own reaction times affected the measurements. Lange's work helped understand why some were consistently faster or slower.
Right, I've heard of that. So it impacted other sciences.
It did. Physiology used it to estimate nerve conduction speed. Pathology explored links between reaction times and neurological conditions. As one researcher, Beneg, put it, psychometry measuring the mind was a general method. Plus, the subjective feeling was important too. Muscular reactions felt quick, reflex-like. Sensorial ones felt more deliberate, willed. Linking measurement to inner experience was key for introspective psychology.
Wow. Okay, so this deep dive really shows how what seems like a tiny detail, that 100 millisecond gap found by Lange, defended by Titchener in 1895, wasn't minor at all. It forced psychologists to grapple with attention, measurement, introspection, and even the practical application of their science.
It truly did. It was a foundational debate. It helped establish the very idea that complex mental life could be broken down, measured, and understood scientifically, paving the way for cognitive science later on.
So next time you quickly hit the brakes or snatch your hand from something hot, maybe take a split second to think, where is my focus? On the warning sign or on the action itself? It's fascinating to think how that tiny shift in attention connects back to these foundational debates about how our own minds work.